Let's take a look at the idea of using trig functions to eliminate parameters. Now, as an example, let's start off with x equals h plus a cosine of theta. And then y equals k plus b sine of theta, where our parameter here is theta. Before we looked at it as t, now we're looking at the parameters being theta. Well, this implies that x minus h over a is equal to cosine of theta. If y equals k plus b sine theta, that would then imply that y minus b, fix that h, it's kind of messed up, y minus k over b is equal to sine of theta. Now, you recall cosine squared plus sine squared is 1. That would then imply that y minus k over b squared plus x minus h over a squared is equal to 1. Now, if we have a situation where, let's suppose that a is equal to b, and we're just going to call it r, then what I end up with is y minus k squared plus x minus h squared over r squared is equal to 1, which then would imply that, see, x minus h squared plus y minus k squared equals r squared. This is a circle. This is the equation of the circle where the center is at hk. Now, if a and b are not equal, then we end up with an ellipse. Depending on which is bigger, that would tell us what the major minor axis is for the ellipse. All right, let's take a look here real quick at another example. X equals cosine theta and y equals 3 sine theta. And I want to plot these as parametric equations, then find corresponding rectangular equation. So let's start off with trying to figure out what my points are going to be when I plot this thing. So my parameter is theta. And then I'm going to have x, my x coordinate, and my y coordinate. And I'm going to work on, it doesn't say what the domain is going to be here. Let's just go 0 less than or equal to theta less than or equal to 2 pi. So I'm going to start off with theta 0, then go to pi over 6, pi over 4, pi over 3, and pi over 2. Work in the first quadrant there for a moment. Well, x is cosine of theta, so cosine of 0 is 1. Y is 3 sine theta. Well, sine theta is 0, so 3 times 0 is going to be 0. So my first coordinate is going to be at x equals 1, y equals 0. Now, pi over 6, I'm going to have root 3 over 2, which is approximately 0.87. And, of course, this is going to be 3 times a half, which is 3 halves. At pi over 4, I'll have root 2 over 2, which is approximately 0.71. And for sine, I'm going to have 3 times root 2 over 2. I'm sure I should have said for y, which is approximately 2.12. Pi over 3, x is going to be a half. And y is going to be 3 times root 3 over 2, which is approximately 2.6. And at pi over 2, x is going to be 0. And sine is 1, so 3 times 1 is obviously 3. So let's just go ahead and plot this first quadrant. Let's see, x goes out to 1. So let's do this in terms of 0.25, a half, 0.751. That should help me a little bit with my scale. And then y goes to 3. So obviously I'm going to lose my scaling here because there's no way I'm going to get 3 in the same scale. I should drop it down farther, but that's okay. You get the idea. 1, 2, 3. So let's figure out what these points are. I'm going to have the coordinates 1, 0. That's right here. Of course, this is x, y. And then when x is 0.87, which is like right in here someplace, y is 3/2. That's 1.5. So I'm going to be roughly here. So it's going to come up like this. When x is 0.71, which is roughly in here, y is 2.12, so that's just a little bit more than 2, so I'm going to be roughly here. When x is 1/2, right here, y is going to be 2.6, which is roughly right in here. And when x is 0, obviously the origin, I'm at 3. I'm right here. So clearly, this is going to continue this pattern, come down to where x is -1, come down to where y is -3, and then right back up. Now, obviously, an artist I ain't. The way I kind of drew it almost looks circular, but that's only because I kind of messed up on my scale. Clearly, this looks more like this. It's an ellipse. So let's go ahead and convert this to rectangular coordinates. I know that x equals cosine of theta, and y equals 3 sine theta. That means that y over 3 equals sine theta. Cosine squared plus sine squared equals 1. So cosine squared is x squared plus y over 3 squared equals 1. Well, that implies that x squared plus y squared over 9 equals 1. That's the basic equation for an ellipse, where my minor axis has a radius of square root of 1, which is just 1, sure enough. And then the major axis has a radius of square root of 9, which is 3. Sure enough. So let's go ahead and jump to the calculator real quick, and I'm going to graph this. Now, I already put this in. Let's take a look at y equals. There's my function, cosine t, 3 sine t. And let's just hit a graph. And you can see I'm starting off here, going up to 3, coming back down just like I said we would, coming around to, this could be -3, right back to x equals 1.